number 4 on the 5th quiz, by far the most challenging. We have a monkey being pushed up a hill in a sled. We're told that the monkey has an initial velocity of 4.0 meters per second. We want to know how far up the slope the monkey goes. What that means is at some point that monkey is going to come to a stop because of work done on the monkey sled system by 2 forces. Friction and gravity, since we're pushing this monkey up the hill. So remember, this is tricky because we always think of friction in a situation like this operating back up the hill in opposition to gravity. But since the sled is moving up the hill, friction always acts, you have to remember, in opposition to gravity. So the force of kinetic friction is down here. Okay, we've got 2 equations that relate work and mass velocity and force and distance. This is what we're interested in getting, is our delta x. We know, so we're first off, we're going to set these 2 equal. So f delta x cosine theta equals 1/2 mvf squared minus 1/2 mvi squared. We're looking for the point at which the monkey comes to rest. So we know that this zeroes out. That goes away completely, which is nice. It makes life a little bit easier. Okay. At this point, we have mass, we have initial velocity. We can figure out the net force on the monkey, and we can figure out that. So let's rearrange to solve for delta x. Delta x equals -1 mvi squared over 2 f cosine theta. In this case, the work being done on the monkey sled system is at what angle in relation to the direction of the motion? It's 180. Because the work being done on the monkey sled system is back down the hill to stop it, but the monkey sled system is moving up the hill. So this is going to be cosine of 180, which is basically going to cancel out that -1. Okay, let's figure out the force on the monkey that's doing the work to slow it down. So we've got the force of kinetic friction. We also have the force of gravity on the x. We're given a couple things. We're given mu k, 0.20. We know that mu k equals fk over fn. This goes back to chapter 4 stuff. You have to do a sum of forces on the y. So sum of forces on the y equals 0, and it equals f of g, well, f of n minus f of gy. So f of n is equal to f of gy. If we look at this, f of gy is going to be mass times gravity times the cosine of 25. So Fn equals mg cosine 25. Okay, we can solve. Pardon? No, because x is sign. Yeah, because there's your f of gy, there's your f of gx. But you know, I will tell you that I had to do this problem twice because this was when I drew from the book. So I had an answer. I knew what the answer was. And I initially assigned cosine to f of gx. The reason I did it, if you're a visual learner, beware. I stuck my f of gx up here, moving it in parallel, and then I looked at the 25 and went, oh, okay, it's adjacent. No, it's not. Not when you're looking here. So be really careful. It's an easy way to trip over your own feet. Yeah, I did it too the first time. Okay, so we've got that. Let's go ahead and solve for f of k. So mu k Fn equals f of k. So mu k times mass times gravity times the cosine of 25 equals f of k. We know that this force is equal to the sum of the force of gravity on the x plus the force of kinetic friction. So let's do a quick sum of forces on the x. We have, well, they're equal. Well, here's what we know. F of gx is going to be mass gravity sine of 25. Let's skip the sum of forces. So, force of gravity x, sine 25, mass gravity. We don't actually have to do sum of forces for that. So then if we back this out, -1 times mass times VI squared over the quantity, this is messy, 2 times. This F is equal to the sum of Fk and F of G x. So we have mass gravity sine 25 plus mu k mass gravity cosine 25, and this whole mess, I'll stick it over here, is times cosine 180. You can factor out a mass gravity if you want. You don't have to, so you can do some tricky little algebra bits with it. If you plug this all in, you get a delta x raw answer of 1.35042,981 meters. And so with sig figs, delta x equals 1.4 meters. So monkey doesn't go very far. Okay? Questions, comments, concerns? Okay, I'll stop the video. You're in study hall.